photodiode. This is the symbol of photodiode. In case of LED, this arrow were going outward from this diode, right? But in this case, this symbol has opposite direction of those arrows. Okay, so this arrows represents the light that is going to incident on the junction of this particular diode. Okay, so this triangle, uh, yeah, represent the anode, while this dash represent the cathode. This is very symbol. This is a very simple symbol of this LED. Construction. Okay, so yeah, it is to be formed with the help of both P regions and N region. So we form a N region, right? And on this N region, we are having this P region, right? When this P and N region gets connected, right? So at this joint, we get a depletion region, a PN junction, right? And when this PN junction is subjected to the light intensity, means the radiation of this light, okay, but so it is going to change the characteristics like resistance and the conductivity of this particular diode. Okay, for connection purpose, here anode is connected a metal, yeah, connected at this P region, and this N region, okay, it is having this cathode, right? So a metal is connected here at this cathode terminal. Okay, so this is the structure or construction of a particular photodiode. Okay, let's just see the working. Suppose this is what photodiode, right? Okay, this is the P region and this is the N region, and at this junction there is what PN junction formed, right? And this dash right represents the what depletion region. Okay, so this diode has to be operated in reverse bias condition. Means what? This P region is connected to what? Negative potential, right? And this N type region is connected to what? P positive supply, right? So this was the reverse bias condition, right, for any diode. Okay, so when this diode is going to operate in reverse bias conditions, so the depletion width is larger. Okay, so this is the larger depletion width across the length of this complete device, right? And as soon as the voltage will increase, this depletion region will increase. Okay, so the amount of depletion width is going to determine the reverse resistance, right? And whenever the diode is operating in reverse bias mode, it is going to offer a very huge reverse bias resistance, means so that no current is going to flow within this diode or within this device, right? So that is why whenever particular photons or a particular intensity of light is incident on this depletion region, so what is going to happen is that those charges that are present in this depletion region, right? So they are going to get some energy from these incident photons. Okay, and after gaining those energy, those electron and hole pairs will be generated, right? Electrons and hole pair will be generated within this depletion layer, and because of this, as more number of charges are being generated because of the incident light or incident radiation within this depression regions, so as more number of electrons or more number of holes or more number of charges are increased, so we can say that the conductivity of this particular region has been increased. And so as the conductivity has increased, resistance has decreased. And so because of this, as number of charges are increased, so the current that is going to flow within this device, even though it is operating in reverse bias condition, a minute current is going to flow, right? And this minute current will increase because of increase in this number of charges, right? Conductivity will decrease, resistance will decrease because yeah, because electron hole pairs are increased, right? And because of this in charges has increased, and so current will for fear of the value of the current will be more, right? uh, when when there is no radiation, right? So if we try to plot the graph according to the intensity and according to whatever the reverse voltage that is applied. Suppose, so we have to operate this diode, right? We have to operate this diode in reverse bias conditions. So we are plotting this graph in third quadrant, right? So this is what horizontal axis is going to represent the reverse voltage applied across the device, and this y-axis, that is negative values that are going to represent the current flowing through this device. So suppose no current, no, sorry, no radiation is applied, or no light intensity is incident on this junction. So as diode is reverse bias, a minimal current, that is because of the minority charge carriers will flow. Okay, so when, yeah, when no light intensity is present, so at that time the minority current that is going to flow, this will look like this, right? This current. Okay, so during this dark period, means no light intensity is present, current, a very minute current will flow. We will call this as a dark current, right? Means the value of current that is going to flow when no light intensity is applied, means there is a dark condition. So this current is called dark current, right? Okay, so as soon as the reverse voltage we are increasing, that current seems to be what increasing, right? Okay, but we have to fix it at a particular voltage, right? Okay, so we will define a particular range of operation. Suppose this minus 5, right? So the operation condition will be from 0 to minus 5 for this particular diode. We can say it, right? Now suppose we have light incident on this particular diode. So charges will increase. So as soon as charges is increase, current will increase. So suppose 1000 lumens of yeah, uh, light intensity is incident on this diode, then so because of increase in charges within this depletion area, the current will be increased, right? So suppose this was something like 10 ampere, 10 microampere, right? So after increasing the intensity, so current will increase to 100 microampere. So likewise, so we will see that this current has shifted to downward, means there is increase in current. Okay, so for all those values, for all the values of reverse voltage, current has been shifted from dark current to this particular value 100 microampere. And suppose we further increase this intensity to 1500 lumens of light intensity. So again, there will be more increase in current. Okay, it will shift from 100 microampere to 200 microampere. Likewise, the intensity of the incident light is going to affect the current flowing through this device. So this is how this is will increase. Then 100 to 200. Again, if we increase more light intensity to 200 lumens, then it will move toward this 300. Then again, if it is increased by 500 lumens of intensity of the light, then it will again move to, yeah, further current to up to 400. So yeah, this is how light intensity is going to affect the amount of charges within this device, and so the current within this device. Okay, yeah, if you plot the relationship between the intensity and the reverse current, right? So we will find this linear relationship, right? Okay, as soon as this intensity is increasing, the current that is flowing through this diode will also increase. Okay, so this is what forward characteristics we can say, or yeah, there is a plot between intensity of light and the current. Okay, and this was the plot of what current induced according to the what different voltage, reverse bias voltage. At the same time, we are increasing this light intensity. Okay, yeah. Applications, there are various applications because it is going to sense the light intensity, so we can use it as a sensor where we have to monitor the light light conditions in particular room or particular industry, or particular environmental conditions, you can say. So if we have to count number of yeah, number of rpm, rate per minute of a particular wheel, or car's wheel, or a particular, you have to count number of objects, flowing, going through this assembly line, or in industries, right? So we can use this system. So yeah, how, let us see. Okay, right. So this is one of the sensor, right? What you have, this one of the terminal is going to, yeah, emit light, and this terminal is going to, receive the light. Now, so here, there will be a photodiode, and here will be a LED. will, um, yeah, emit light, and there is a photodiode which will sense the light here. So when a object comes within this particular gap, so what will happen, that light emitted by this LED here will be blocked when a particular object is going to be present here, and after that this photodiode will not receive any light, so it will provide a very minute current. Okay, and when the object is removed from the this gap, right? So maximum light from this LED will incident on this photodiode, right? And it will generate maximum current. So it will generate a pulse. Whenever the object is going to be present within this gap, no current will be generated. When minimum current will be generated, and when object is removed within this gap, then maximum current will be generated, means pulse will be generated. So this is how we are going to sense the presence of object, and how many times the object has been there. Okay, so how many times, so it will give the fluctuation in the current, means a minimum value of current and maximum value of minimum value of current, maximum value of current. So how many times it fluctuation has been, and we are going to count that. So we will get the RPM, or we will sense the, yeah, whether there is object present or not. So this is one of the application, right? Okay, so this was the photodiode.